So good afternoon, and I think I'm probably at or your last session today, so I'll hopefully manage to keep you awake. My name's Dave Banthorpe, and I'm the Worldwide Portfolio Manager for Unified Communications at HP. Part of that is I lead as the Chief Architect for Unified Communications across everything that we're doing in TS. So that's technology services, so we're a consulting arm of HP. We're doing large complex deals for our customers, 100,000 seat, multi-region, multi-site type deals, often dealing with migrations from legacy and existing PBXs and complex integrations. And part of my role, I also work with the rest of HP's product groups, in specific with HP networking as well, looking at our own products for Lync and actually how we can best provide products to the market to support Microsoft Lync. So today I'm going to spend some time talking around strategies and some technology-specific stuff to enable you to have successful enterprise voice rollouts. So we're specifically looking here at enterprise voice. And we're going to start off by looking at some of the design considerations and some of the things that will trip you up early on, post-pilot, that will not allow you to succeed in your voice deployment. Quite often pilots will be very successful, there are a short number of users, but when you start moving out into the wider enterprise and larger numbers of users and trying to do bulk migrations of branches and things like that, there are often things that will actually trip that process up. And keeping the user happy from day one is absolutely critical to successful rollouts, and not just looking at the technology, not just looking at how the application's behaving, but your users. So at the moment, everything's talking about the cloud. If you go on the net, everything's talking about everything moving to the cloud, be it a private cloud, a public cloud, a hybrid cloud. And when we start looking at legacy applications, and when by legacy applications, I don't mean necessarily old, but we look at database applications. They have no worries really about network quality. So think about data transfer, or you're looking at Exchange and Outlook. They'll back off nicely if the network's behaving badly. And the way that the applications have changed over the years, the user will actually see no impact. In fact, in often cases, they won't even notice that the network's got a problem. So Outlook with cache mode, the user has no visual clue unless he's really looking closely that Outlook has actually gone to sleep for a little bit. He can't talk to the Exchange server. But of course with voice and video, that's totally different. The moment the network is impacted, not only are you impacted, but of course everybody else is impacted, and fundamentally the business is impacted. But as we move into the newer world today, that we're seeing the very mobile-driven world, we're seeing a whole variety of devices coming out, tablets, smartphones, soft phones, etc., moving away from the way that voice was traditionally handled on a dedicated handset, a dedicated phone. And so UC is bringing new modalities, desktop sharing, a lot of video conferencing, and all these things are going on at the same time from the same application. Previously, you'd go to a dedicated video room. Think back to the days where you'd had to book out a video room, the admin would have to book it out for you, it would have a dedicated network, maybe ISDN dial-up or something like that. The phone is actually running on its own Cat3 system, be it an analog or even an older IP-based PBX. But they're all separate applications, they're all running over separate networks, they all had separate managers, separate network administrators, etc. So as we move forward with UC and specifically with Lync, what we're seeing is that all of those modalities are now coming down and being funneled out of one client. And when you look at the desktop, the soft phone, or the soft client for Lync, everything's coming out of that laptop. How do you trust the application? How do you trust that that is being sourced, that traffic is actually coming from Lync and it's not coming from some spurious application, or someone's not trying to do some kind of denial of service attack on your network? So voice and video is very latency sensitive, very susceptible to jitter, is very bursty. So you have to keep that network traffic separate somehow from your data network. Just sort the audio out. There we go, thank you. So one of the other things is that we're thinking about cloud-based services. Most of that traffic is going from the client to the cloud and back again. And when I say cloud, you can replace that word with data center if you're not doing cloud-based services. But that traffic is going from your client over the WAN to the data center and back again. With UC, majority of it is client to client. So yes, there is going to be a lot of traffic going back to the data center. There'll be signaling traffic. There'll also be collaboration traffic if you're running multi-party conferences, etc. And they're obviously being hosted inside the data center. But a lot of traffic is still going to be going client to client over the LAN. And that traffic won't have been there in the past. So that's something we have to deal with. So the first section, I'm just going to come through some lessons learned from the field. And what I mean by that, excuse me, is these are some of the things that we've found out that can stall a project, can stall a rollout as you move from pilot to deployment. When my colleague presented this at TechEd America a few weeks ago, one of the guys came up to him afterwards and said, I had exactly this problem. It turned out that after the pilot, which worked absolutely perfectly, pilot wasn't a problem. When they went to production rollout, Lync was consistently failing. And it turned out that the network manager, the guy in charge of the underlying networks, was a Cisco fan. And he was purposefully preventing Lync from getting quality of service. So he was ensuring that Lync was failing. So he could turn around to management and say, told you so, Lync wasn't ready for prime time, it's not ready. Okay, well, there was nothing wrong with Lync. What he was doing was actually fiddling around with the network to ensure that Lync failed. How do you avoid those kinds of scenarios? So what are some of the pitfalls? Generally fall into two categories. Insufficient planning. Start here with network assessments, capacity planning. So, as I was talking earlier, the traffic patterns that we're seeing from a UC deployment are totally different from what you've seen today if you're using more database applications. Your network will not necessarily have been designed to take that traffic or to handle that traffic in the most efficient manner. Your WAN links may not be provisioned correctly for that traffic. If you're using Wi-Fi, how many of you I've seen people who've got Wi-Fi in your offices and etc. But were they put in recently and designed for voice traffic? Or was it just for ad hoc, BYOD, bring your tablet in, get a hold of your mail? That means they'll work where they were meant to work and designed to work, i.e. in the meeting rooms, in the conference rooms. But walking down the corridor, walking down to the canteen to have a coffee, etc., where most people are going to be on the phone, that's where you're going to have your black spots. So your Wi-Fi network needs to be looked at in terms of coverage and black spots to enable you to be able to deploy a soft phone capability in the office. Planning PSTN versus WAN capacity. If you've got a legacy voice infrastructure, you're going to have potentially a lot of legacy, and I mean by legacy E1, T1, ISDNs, what have you, PSTN connectivity. But as you move to a UC-based solution, an IP-based solution, your WAN costs for that amount of traffic can be considerably cheaper than the PSTN costs. But you don't want to throw away all your PSTN traffic or your PSTN links because you need those for resiliency. So, don't plan to move everything over to the WAN as soon as possible and throw away those PSTN links because A, you may need them for backup, but B, you want them for some resiliency services. You want to keep some of those PSTN services for later on. Simple items that can impact audio quality. Classic one was contact center, and they were complaining that the audio quality was absolutely terrible. And they looked at the networks was fine, QoS was fine, network bandwidth was fine, the servers weren't impacted, they were running absolutely fine. When they actually got down to the bottom of it, contact centers, are open forum environments, cubicles, etc. So everybody's on the headsets, but they're generally quite noisy places. So this person had cranked up the gain on the headset So their headset was now picking up a lot more extraneous audio from everybody around them. So it was a case of just training the users to how to use the devices, not just Lync as an application, but how to use the devices, the peripherals that are actually added onto their desktop, their laptop, what have you, to give them that experience, how to use those properly. And then that got rid of the problem. So it wasn't a technical issue, it wasn't a deployment issue, it was a user training issue. Another one, VPNs. So how many people do Lync over VPN? People who have got it. Okay, so one of the things that can cause problems with Lync over VPN is that the way that the SDP packets come back from Lync when the call's being set up, quite often will have the internal IP address as preference to the edge server addresses. So if you look in the SDP headers, you'll see the IP addresses of all the candidate addresses that the client can connect to. And what ends up happening is you end up throwing all your voice traffic down the VPN. And that may not be optimal. And what you want to do is actually route your audio traffic through the edge server. There's no need to send your audio traffic down the VPN. You want your corporate traffic to go down there to get to SharePoint, get your file shares and what have you. But let your Lync traffic go round the outside and through the edge. So you need to think about, okay, I need to put some firewall rules into my VPN client or into the desktop firewall to say any traffic going to the Lync servers that's audio, block it from going down the VPN, because Lync will then go, okay, I can't send it down the VPN, I'll try the edge route. And your voice traffic goes through the edge. And what you often find is with voice traffic going down the VPN, poor quality. And again, poor user experience, people that start complaining and the message starts going up the tree in the organization. The example I gave earlier about the Cisco guy and the network manager blocking Lync, that all came down to poor communications. Getting the key stakeholders involved early on in the project before you go into production. And who are those key stakeholders? Well, they're beyond the obvious. So it's not just the network admins, the IT admins, the existing PBX admins. It's HR, it's training, education, because you've got to think of the end users, as I mentioned earlier. You've got to keep those guys happy as well as keeping the infrastructure side happy. So a lot of those people quite often will see their career light going, the exit light blinking. They're thinking, well, when Lync comes in, my job's done. I'm going to go out of here. So I'm going to make it hard for you to deploy Lync and hard for you to actually get it rolled out. So you've got to get them bought into the process. And more often than not, you'll need their help. And they'll suddenly realize, oh, actually, this is quite interesting. I might want to stay around and be part of this. So keep those key stakeholders involved. Again, program management, that trips you up as well. Again, legacy voice, legacy video often had dedicated admins. So dedicated PBX admins, dedicated PBX budgets. So getting those guys involved early on and actually ensuring that program is properly managed for your needs so you can actually roll out Lync successfully. Network assessments. So when we start talking about network assessments, you've really got to get in and look at the existing usage models and the call flows that are there today. All too often, these sorts of projects will fail because people say, well, we've rolled out Lync IM&P, we're going to do a bit of web conferencing, everything's going to be fine, let's just flick on the voice because everything must be fine. And they haven't taken into consideration exactly what the voice traffic was that was going over the PBX before they start switching it over to Lync. Often those PBXs I mentioned earlier running on their own dedicated networks, often Cat3 or something like that to the desk or a TDM-based PBX. So that voice traffic never went anywhere near the data network until someone flicked the switch. And now all that voice traffic, when they started migrating users to Lync, is now hitting the network. So you've got to properly understand that. Looking at sites and branches often is a bigger problem as well. It's once you've got the data center rolled out, the data center sometimes can be the easiest thing to do because that's where you've got your core gateways connecting to the PSTN, that's where your main trunks are coming in. When you start doing your branches and start doing branch cutover, where you're flicking over users from the old PBX to maybe a survivable branch appliance and gateways in the branches, that's where you've got to have site cutover plans in place. You've got to have real good processes in place to handle that part of your migration. You need to inventory the existing PBX equipment as well and actually know where where are all the call flows going? So why did that call from this office to this office route through there? Was it because it was badly set up originally, or is there something real why it has to flow through there? Because quite often you can look at the old voice topology and think, I could do that better. We can actually route this traffic a lot more efficiently, but sometimes there's a reason why it has to go through those locations. And don't forget shared services. Shared services can really cause problems, more from the perspective of getting them changed. What I mean by that is you need to add new rules. You need to add new rules to your firewalls, your reverse proxies, etc., as you're rolling out Lync. And often in larger organizations, they may be outsource managed. So they may not be managed by people in that company. And suddenly what you think is going to be, it's only going to take 3 days to do those, becomes something they've got to get a statement of work, they've got to get a project kicked off to get the load balancers changed and all that kind of stuff. And all these things just start escalating and rolling down the hill towards you, and at the end of the day, just stalling the whole project. Interesting thing about using savings to fund migration. I've got a case study later with some figures to back this up. But the key thing is, Lync will save you money at the end of the day. That's part of the ROI and the TCO that you sell to your customers and that we sell to our customers, that Lync is going to save you money. But don't throw that money away straight away. So if you're going to save thousands of dollars by moving to Lync Voice, don't suddenly go, there you go, company, you can have that money back. Keep that money back with you to fund further rollouts of Lync services and your UC infrastructure, and then give the savings back. All too often, people are keen to keep management happy, keep the higher echelons of the company happy, and hand that money back too quickly, and then struggle to get funding to do the next phase. So endpoints, we mentioned about headsets. I struggle daily trying to convince some people, who are using Plantronics headsets or other Bluetooth-based headsets, to always stick the dongle in the PC. And they complain. They say, well, it works without it. I compare it to the Bluetooth stack on the device, and it works fine. I said, well, it may sound fine to you, but to everybody else, it sounds rubbish. And the reason those dongles exist and the reason those peripherals exist is to provide the high bandwidth Bluetooth stack to get the high quality audio that you expect with Lync, plus also additional hook switch capabilities in terms of call control from the headset, etc. So this is where it comes down to user education, getting those users happy, because you may have done everything you need to do on the network and make sure Lync's running absolutely fine. But if someone's using a duff headset, they get a bad experience. They turn around to their boss and say, hey, this is rubbish. I'm going back to using my mobile phone. And more often than not, they'll never tell IT. They'll just stop using it. Most people, give them a chance, they'll find a route to go around you. Little points about use cases that Hot Desk Conference when I was working from home, know your users. Know what devices are appropriate for which use case to ensure that they get the best user experience. So we talked about strategy and roadmap, keeping them informed of what's coming, keeping them up to date with the changes, but working with the procurement processes to make sure your procurement processes are in place to allow your users to go and buy those headsets, buy those phones, buy the devices they need as and when you start rolling out. If you're getting into a mass migration, if you're doing like an 80,000, 100,000 user migration, these processes need to be absolutely running perfectly so that they can actually go ahead, order their device, get their phone, so that when you migrate that site, those users have all the devices they need. So let's look at some network design considerations. Video. I don't know how many people do video. I mean, we're going to talk primarily around voice here, but when we're talking about network design and quality of service, video can put 10, 20, 30 times the amount of traffic on the network and load on the network as voice. And we sell Lync as the concept as being so easy to escalate from one modality to another, and just it's click of the button, turn on the video. Click on the button, make a call. This is why it comes back to that whole planning concept. What is your usage model going to be? You don't necessarily know up front exactly what it's going to be, so you need to make sure you allow capacity for that initial ramp where everybody goes, hey, it's a new shiny toy. Oh, I'm going to turn this on, I'll turn that on, and your usage goes right through the roof. Your network gets hammered. So you need to make sure you've got some processes in place to allow for that. So some of the main things, I'm going to go follow on after this. I'm going to particularly look at QoS. But here are some of the things that you need to understand. You understand your network topology and the real-time media flow. So as I was saying earlier about VPNs and things like that, where is the voice traffic? By default, if you don't do anything, where is your voice traffic going to flow now? Okay, you suddenly switched it to Lync, suddenly switched it to a laptop. If you're even running an older IP PBX today, those phones will have a dedicated drop to the desk. Those drops will be on a dedicated voice VLAN. Okay, even if your laptop is plugged into the slave switch point on that phone, that laptop is now running on an untagged VLAN, on a data VLAN. It doesn't use the voice VLAN that the phone's using. So you now move your voice traffic from the old phone onto Lync. You're not going to change any of the networking. You're just going to move the capability from the IP phone onto your Lync client, and suddenly that voice traffic is now going over the data VLAN, not over the voice VLAN. Because if you don't change anything, you don't do anything, you've just suddenly moved it across. So you need to be aware of, if you don't make changes, what will actually happen, and that will help you kind of analyze and look at some of the choke points that you might have in your network. Provide sufficient WAN bandwidth. So get an idea of what your conferencing usage is going to be. If you're moving dial-in conferencing in from a hosted service provider into Lync, that you can get some pretty good data from that, for example, because you should know what your outbound call rates are going to be from your existing PBX out to the dial-in conferencing service, be it an intercall or something like that. You can look at those call rates, and you can use those to help plan what your traffic's going to be from your users now sitting in their branch offices, into the data center, to the Lync dial-in conferencing bridge. So if they're not actually going via the PSTN, but they're just going to use a VoIP call from Lync to join to that bridge call, you can actually get an idea of what that traffic plan is going to be. We'll talk some more about QoS, but it's all about deploying a consistent policy. And there are a few things in there that can trip you up, and a few things that, as mentioned, that Cisco guy, that if you don't understand what's going on the network today, will cause problems with you trying to deploy a QoS policy for Lync. Resiliency, obviously that speaks for itself. You start moving your voice traffic from a legacy TDM-based PBX onto IP-based, onto your data networks. Think about the resiliency for voice. It's very, very noticeable when voice traffic disappears. And often people don't complain about the old PBXs because they tended not to have the same problems that a data network can have. So make sure you're dealing with your resiliency specifically from the branches. Do you need to put in survivable branch appliances, or are you going to run redundant WAN connections from the branch? How are you actually going to deploy that capability for those people not on the main campus corporate networks? Don't forget, obviously, PoE for the phones and new endpoint types. If you're going from a legacy PBX system to Lync, and you can deploy the Lync phones, they obviously need PoE. You can run them off a power block, but you don't want all those power leads lying around on the floor everywhere. Security and monitoring. So do take them into consideration. Security becomes a bigger issue these days with BYOD. People bringing their own devices into work, and the whole mobility campaign. How do you provide, universal access, but securely, to ensure that people can actually run? They're going to if you're going to allow them to run the Lync client on whatever tablet they bring into the office on the corporate Wi-Fi. How are you going to secure it? How are you going to trust it? How are you going to make sure that they're not going to do anything malicious with that non-corporately provided device, although it's running the corporately provided Lync client? And monitoring is key. Monitoring is absolutely key. As I said, often when you start turning these features on, your usage is going to go through the roof for a little bit, and then it'll come back down again. Make sure you're monitoring. Make sure you're looking at things. Really use the QoE server from Lync to help you with your voice deployments. Some really nice features in there if you're going into the SQL reports and looking at site-by-site based QoE metrics, because that can give you an idea of poorly performing branches. So when users start complaining or there's some user feedback saying things aren't going as well as they should be, start using that data in the QoE database to look at what site, what subnet, where that traffic was coming, and then start backhauling and looking at your overall problems. So I mentioned earlier about legacy PBX, LAN 1 is not ready to handle VoIP quite often. It's not necessarily all the case, but often branches will need some kind of upgrade to enable them to handle the voice traffic properly. And understanding the concurrency. What is more cost effective, PSTN or more WAN bandwidth? You know, where's that money best spent for your Lync deployment? We mentioned Wi-Fi earlier, so I'll skip on from that one. So why is modeling necessary? You need to understand that amount of bandwidth that Lync's going to generate on the network. And you typically don't know what modalities users are going to use. You can say, well, the company says, I want all features. I want voice, I want conferencing, I want video, I want web conferencing, I want desktop sharing. And you can go through the TechNet numbers, you can take all the data that's provided over the typical usage models. But at the end of the day, users are human, they're not machines, you can't model exactly what they're going to do. You need to do as much modeling as you can. You won't get an absolute number out from day one, but you need to do as much as you can. And, 6 months down the line, your traffic profile will be totally different again. People just get used to using it. They'll settle down to the vagaries of moving from an old phone onto a VoIP client running Lync, and they'll get used to that. They'll get used to the way of working. They'll get comfortable with doing things. They'll realize actually maybe flicking the video on for every call isn't the right thing to do. Maybe I won't escalate to voice straight away every time. It's like that new shiny toy capability. So what are the provisioning challenges when we're talking about QoS? There are two general boundaries that really cause, not problems, but areas of concern that you need to think about. So there's the user access layer, and there's the enterprise edge out to the service provider. So at the user access layer, we want to mark the traffic at the point it's generated, at the point the traffic is coming in. That's the best place to put the QoS marking on. The DSCP markings, any rate limiting, that's where your network is going to be its best aware of what is generating the traffic. So is it Lync generating the traffic? Is it a Skype client? As I mentioned earlier, a phone will typically sit on a dedicated voice VLAN. Lync phones support LLDP MED. They will actually go and discover what is the right policy. The policy will be pushed out to them, so they will automatically start using the right VLAN tagging, the right DSCP markings for the voice traffic. A laptop, the network doesn't really know. I'm just starting running a soft phone client on this. I was running Outlook before. I was sending data. I was doing file transfers, and now I'm running VoIP traffic. You're not changing the identity of the device that's touching the network. All you're doing is you're putting an application on that device now that's going to now start throwing out that VoIP traffic. And the same with the BYOD devices, with tablets, etc., on Wi-Fi. But if you can do it at the user access level, then the rest of the campus environment, the main network switching for the rest of your enterprise will be much easier to manage. Your QoS policies over the rest of the network can be really simple. But if you can't do it at the access point, where the traffic is generated, then your central policies are going to get a lot more complex and harder to manage. But then when we start looking at the enterprise edge, we've now got to start remapping things. Why is that? Well, the service provider won't necessarily use the same DSCP markings as you want to use internally. DSCP markings aren't mandated. There's no one rule that says you must mark this traffic using this flag. At the end of the day, you can set it to what you want. But often you might go from an 8 policy DSCP policy where there are 8 different flags to one that's only got 4, that's now grouping 2 levels of traffic into one DSCP marking. So you've got to remap it at the edge when it goes out to the service provider, where it goes over your MPLS network, over your WAN. Your emission control and policy-based routing are all different at the enterprise edge. So as I mentioned earlier, so typically the phones were trusted, conditionally trusted on the laptop. Untrusted, yes, you probably want to remark everything because you just don't trust what they're throwing on the network. You're going to want to remark it. You want to say, right, this, whatever this is doing, I'm remarking it. I'm not trusting anything that device is telling me. Now we know from Lync, when you're deploying Lync policies, Lync QoS policies, the phones will automatically pick up one from Lync directly. The laptops, will, if they're corporately owned and therefore part of the Active Directory domain, can get their QoS policy for the client, for Lync, from group policy. But the BYOD device isn't domain joined. It's sitting on your corporate network, perhaps, on a specially provisioned Wi-Fi network, but it won't get given any DSCP markings. It won't get given any QoS policy. So the only QoS policy that thing's going to generate is what the device is going to generate. And if the user's a network admin, he might be hacking away quite merrily generating stuff. So generally there are about 5 different ways that we can achieve QoS. The first is classification, and that's what I've just covered. Identifying the source. Where did it come from? What is actually generating that traffic? Scheduling and queuing, so pacing the traffic in queues based on what you have identified. So once you know what the traffic is, we now start grouping it and saying, well, this goes in this queue, this goes in this queue, and this goes in this queue. And then those queues then get marked with priorities. So this is where you start putting your DSCP tags on that queue and say, well, this queue is going to get expedited forwarding because it's voice. This traffic is going to get pushed lower down in the priority stack because it's not voice traffic. And I know this is going to be general data. I'm going to shove it down the bottom. Call and mission control then comes into play from a Lync perspective, because even though you're tagging your traffic and you're saying this device is generating this voice traffic and therefore I'm going to give it this DSCP marking, you still might want to limit the number of calls. You know, if your pipe can handle 10 voice calls, when the 11th voice call goes through, might be okay, that user will start to notice some deterioration. When the 12th, 13th, and 14th call goes through, not only are those people affected, but all the other 10 that are currently in progress are going to get affected. So you start affecting everybody. It's not just the last person to join and the last person to start a call is going to get affected. So you're going to want to put in some call and mission control in to actually stop the pipe getting overutilized. And that's another thing that, you know, going back to what I was saying earlier about making users aware. You know, that necessarily wasn't a problem on an old phone system because they were hardwired. There was no shared pipe. It was a hard patch from the phone to the PBX. So making users aware of, okay, this might happen. The world isn't going to end. You know, try again in a minute. And then rate limiting gets done at the access switch layer. So rate limiting is saying, okay, I've done everything I can to identify the traffic. I've queued it. I've given it markings to give it the priority. I've got call and mission control on my overall WAN pipes going between these sites. But now I might want to put some rate limiting on the access switches just to stop any denial of service. So someone firing up some app and saying, well, oh, okay, so if I run up a little SIP phone and start throwing RTP packets with this DSCP marking, which matches Lync, I can bring the switch down. And he could do. Because if he knows that information, he can actually write something that just floods that switch port. So you might want to put some rate limiting on your access switches to actually keep that under control and stop people sending too much traffic. Also in the branches, you might actually want to just to limit the ports, for example. Some people decide just to limit the ports and say, well, we're only going to allow a certain amount of traffic through these ports regardless, whether it's got the highest priority or the lowest priority, we're just going to limit these ports. And that often will come down to cost. You know, what is the cost of the WAN link? How much traffic? How much are we providing? Or how much are we paying for our MPLS links, etc. So this is an example. This is by no means the way to do it, but this is pretty much recommended best practice for how you should tag your traffic, how you should, when you're setting up a QoS policy, how you should set things. Key thing here is to notice that on the left we've got 8 queues, and on the right we've got 4. And this is just to give you an example of what I was talking earlier about remarking, where you might have to remark queues, but also where you may actually only have a switch or a network infrastructure that only understands 4 queues. Not all network infrastructures understand 8 queues. So you're going to want to put voice, obviously, right nice and high, video, signaling, and then you start dropping things back after that. Now, one of the key things is don't mix UDP data, which is obviously your voice and your video traffic, with bursty TCP data. Bursty TCP data, people uploading files, SharePoint downloads, all that kind of stuff that's just going to go whoomp through the roof and then come back down again. You don't want to put that traffic in the same queue. So generally, the rule is you don't mix TDP, UDP, and TCP. But what you can do, as it shows on the right here, where we've got queue 5/4, we're actually putting the link signaling in the same queue as the video. Because the link signaling, although it's TCP, it's not bursty. And we want to give that a higher priority anyway than general background TCP traffic, because obviously the signaling is the thing that's setting up the call in the first place. Last bullet point there is just a gotcha. Doesn't matter whether you've set up all these policies and set up all the queues, but if you haven't got enough buffering on the switch won't be able to deal with it. So make sure your buffers are big enough on the switch to enable you to deal with QoS. So what does it look like? So it's just a little schematic here. So as I mentioned earlier, an example where the laptop is now plugged into the phone. So the IP phone, this is a Lync phone, so it's sat on a tagged VLAN for IP phones, and we're now using the switch in the back of the phone to give a connection to the PC, but it's just a pass-through switch, and it actually puts the PC on the untagged data VLAN, the default VLAN, on the switch with no L2 priority at all. So when the phone powers up, it will discover the VLAN and CORS via LLDP MED, and it does that by talking to the switch. This isn't a Lync thing, this is the phone talking to the switch. So this will give it, this is the voice VLAN, and this is the QoS policy. Excuse me. So those packets now have a layer 2 priority and the layer 3 DSCP markings. So they've got a good quad setup. But the PC traffic doesn't include any priority. As I said, it's sat on that untagged VLAN with no priority. And sometimes soft phones don't even send layer 3. Now, Lync will if you set up the policies correctly. Okay, so if you set up the Lync policies to actually push out that layer 3 DSCP markings out to the client, it will get it. But other applications on that laptop can still be sending RTP traffic, can still be sending voice, but won't have any DSCP markings at all because they're not an enterprise application. They're not being driven by the enterprise. And generally, we say PC applications can't be trusted. That's just a general rule. You don't trust them until you have more information. So at the edge switch, it'll obviously honor all the DSCP markings from the phone. But what it needs to do now is it needs to classify the soft phone traffic. So how does it do that? Well, this is where the ports ranges come in for Lync. So the ports that are being used for video, for voice, for data sharing, for web conferencing. So obviously by default, the ports are wide open on a Lync deployment. All the UDP ports are being used. This is where you want to start locking them down. So you'll want to actually start saying, right, voice is going to use this port range. Video is going to use this port range. Application sharing is going to use this port range. And why is that important? Well, in a greenfield environment, that may not be a problem. But in an environment where you're actually sharing or migrating from an existing voice infrastructure, and specifically an IP-based system, so Cisco or Avaya or something like that, they could be using the same port ranges. So how does the switch know? How does the network know that that traffic came from Lync as opposed to it came from a buyer? How can you classify it? So you need to make sure that your port ranges don't overlap with their port ranges. This all comes back to what I was saying earlier about doing that network assessment, doing the inventory, understanding the existing PBX environment, understanding the existing network. This is where it'll start to trip you up. Because if you don't know, you can't go out and set these ACLs correctly. So how do we deal with this? So our UC portfolio extends across a variety of things that HP is involved in, all the way through from server storage and networking, obviously, through to our services, our alliances with various partners such as Polycom, Microsoft, etc. And of course, we've got an extensive portfolio around management and service offerings. But our vision for networking is to move away from physical to virtual. You know, today, when you're provisioning your network and you're trying to set up QoS or you're trying to set up your switches, most people are going to have to go in on the command line and actually start tapping away at the switch and doing stuff. Our vision is to actually separate that. We want to take away the need to actually connect to the switch to do something. We want to provide control centrally and then provision the network accordingly based on what is going on. How many of you have heard of SDN, software-defined networking? Okay, I've got one, good. So this is where we start to separate the application and control layer, as I mentioned earlier. So we're taking away the intelligence that's in the switch and putting it centrally at an application layer. So this is a demo I'm going to show you in a minute, video of, and if you're interested in finding out more, visit the HP stand, as I believe we actually have the SDN demo running there in reality, so you can actually see this thing in real life working. But what is it? So software-defined networking, as I said, is all about separating the application layer from the control layer. So our switches and many other third-party switches are enabled with OpenFlow. OpenFlow is a standard, industry standard, enables us to actually communicate and provision those switches centrally. So this is an API. Think of it as an API into the switch to actually tell it what to do. And of course, those switches are our access switches. In this concept here, we're talking about the access switches. They talk over an API to the SDN controller, which is the thing that actually goes out and provisions the switches. And then at the top layer, we have an application. So the application layer is then application specific. So we have a UC SDN application that we've got running here. And this is the thing that's specifically talking to Lync. So it's using an API. We've got a POC, joint POC with Microsoft to develop this at the moment. And we've got an API running off the back of the Lync front ends. And then we've got the API in our SDN controller. And what happens is that as calls are set up, the signaling information received by the Lync server that user A and user B are going to make a call gets sent to the SDN application that passes it down and then dynamically provisions the QoS for that call and then tears it down afterwards. So you don't have to have the complexity of going out and setting out your QoS policy and typing it into the command lines and provisioning your switches and making sure this guy doesn't change from port A to port B on the switch and suddenly gets a different QoS policy because you've done it on a port basis. This will dynamically do it. So what I'm going to do is just run this video.
HP has announced a new cutting-edge SDN application, the HP UCNC SDN application for Lync. With this new UCNC SDN application, HP is now able to connect business applications, in this case Microsoft Lync, to the centralized intelligence of the SDN architecture. The UCNC SDN application automates network policy in a dynamic fashion, unlocking the full potential of unified communications and collaboration solutions through an enhanced user experience. Take, for example, two employees attempting to collaborate via Lync using application sharing. On the top left, we have the user James, and on the bottom left, we have the user Linda. James initiates a call to Linda and then starts sharing an application. As you can see, Linda's user experience is significantly delayed and not synchronized with what James is sharing. This is not a problem with Lync, but rather an issue with how the Lync traffic is handled across the network. This poor user experience is all too common with today's UCNC solutions. In fact, users are not only frustrated by this, they have come to expect this type of experience as the norm. The reality is that poor application performance is a drain on productivity and limits the power of unified communications and collaboration solutions. On the right-hand side of the screen, we have the HP UCNC application in a disabled state. When we enable the application, the user experience is instantly transformed. Now both users are seeing virtually the same information at the same time. The UCNC SDN application has taken call intelligence from the Lync server and used it to implement OpenFlow rules via the HP Virtual Application Network's SDN controller. These rules route and prioritize the application sharing traffic. The end result is a UCNC experience that is rarely seen across today's networks. Another unique benefit of the UCNC SDN application is that it provides unprecedented visibility to network administrators as to what is happening with application traffic on the network. Detailed call logs, including source and destination information, as well as call quality information, is passed to the UCNC SDN application and presented to the network administrator.
Okay, so you can see that in action at our stand, but that shows exactly what happens when QoS is properly provisioned. Right, now that's not doing something additional in terms of QoS, but what it's doing dynamically. So how's that actually working? So here's a schematic showing exactly what we've got running on the demo and what was just videoed. So at the bottom layer, we have two OpenFlow switches, these are standard access switches. And each of those users is connected to a different switch. So you could think of this as two people in different branches, they're not in the same office, for example. And both switches have got traffic generators flowing on them. So what we're doing is we're throwing a whole load of bursty traffic, stuff that would typically be going on in an enterprise whilst you're trying to make a call. So these aren't quiet switches. They're noisy, they're busy. Those connect up to the central core switch and then fundamentally connecting obviously to server, so to the Lync server and to our VAN SDN controller. So as the user makes the call, so James makes the call to Linda, what we're seeing there is the green line is representing the normal signaling that we'll see, the SIP signaling that will be set up for the call between the Lync users. Lync will then, out of its API, will actually talk to our SDN controller and tell it that this link is being set up. But not only the fact that James wants to talk to Linda, it'll tell them which port, on which switch. So it'll nail it down to the port, it'll nail it down to the port ranges being used for UDP. So all the call information is being passed over to the SDN controller. The SDN controller will then determine which switches are going to actually be involved in that call, and will go out and provision the policies on the switches as necessary, dynamically. But as I said, specifically for that user on that port. So if someone else comes in and plugs in a PC into a different port, they won't get that policy because it's been set up dynamically for these users on those switch ports. And then, of course, the traffic will then flow between the two. And what you saw in the demo is when he was turning it from an enabled to a disabled state, essentially what that's doing is that's actioning that would, in reality, happen automatically. Nobody has to go and enable it or disable it. That just allows us to show what happens when it's not turned on and when it is turned on. So what normally would happen, that would just automatically go and provision the switches before the call's even set up. And then tear it down afterwards. So the moment the call's finished, we'll deprovision the switches. We'll take those settings off. No overhead. You don't see any impact on the network of doing this. But what you do remove is the pain of having to go and set up those QoS policies. You ensure that the right policies are set up on the right infrastructure for that call. And also you start circumventing the issues such as that I introduced the session with, that guy purposefully trying to make sure Lync didn't get QoS. Well, this will make sure it does. And not only that, it makes sure that it is a Lync client running on that laptop that gets it, not just any other VoIP client running on that laptop. Because when you start putting DSCP markings on the network, how do you know that the DSCP marking on VoIP traffic A came from Lync and VoIP traffic B came from another application? You don't. There's nothing that will tell you unless you know up front port ranges that are being used, or through the SDN capability, actually identify the source of that call. When we start looking at branches, I mentioned earlier branches are can be quite a problem when you're doing migrations, because that's often where you're cutting over. You've got complex cutover times to do. You've got to decommission equipment. You've got to actually drop and insert the voice gateway, the Lync gateways or the survivable branch appliance into that branch before you start moving users across. What we have is our MSR series routers, part of our FlexPart series. There is a much larger range than the ones I've got displayed here. But what we've now added to these routers is the ability to be an enhanced media gateway for Lync and a survivable branch appliance. So the certification for Lync should be through very, very soon for these devices. But this provides you really good opportunity in the branches, because it's fundamentally at the core, it is a enterprise router with gateway and SBA functionality added on top. So when you're doing your branch refresh, you have the opportunity to put in one device to look after all the voice traffic and all the routing. You can throw away the old router, throw away the old PBX, and just drop this in there and connect that back to Lync. On the survivable branch appliance side, we have 3 different sizes. We have small, medium, and large survivable branch appliances, depending on the scale that you need. And of course, these blades will go into our different routers as necessary based on what you need. Very scalable on the analog side as well. So what I mean by that is FXS, FXO port scalability in these is really high. We've had a number of instances in branch deployments where in the past we've had to deploy multiple gateways just to connect up all the analog stuff that they're not throwing away. You know, what they're going to do with fax, what you're going to do with the fire alarm systems, what you're going to do with the lift phones, what are you going to do with all these other things that are analog connected up to the old PBX. You can't easily switch those over to Lync. You can't put a soft phone. You know, who's going to take a soft phone in a lift? You know, on a laptop or a tablet bolted to the inside of the lift. They still want to use that lift integrated infrastructure, for example. So you're still going to have the need to connect up analog ports. And quite often in a branch cutover phase, you have a lot of analog ports that you need to initially handle and then later pair those back, as some of those services can be moved over to Lync. 2 sets of our phones, 4110 and the 4120. These are the optimized phones for Lync, so these are running the Aries stack. One of the things that we have with ours is that the internal switch inside is gigabit on both of these. And that obviously is really useful if you're going to desk-based deployments and wanting to put a single drop to the desk. You know, there's diagrams I showed earlier with the laptop connecting into the phone, then into the switch. These will actually support gigabit capability. Electronic hook switch capabilities, speakerphone on both of them, which isn't common on all the what Microsoft call the common area phones. And ours is the 4110. And they both support Office 365 now as well. And this is to do with the provisioning and the certificate handling of using the phone directly with Office 365. So that's how we deal with some of the things from our networking. How do we deal with some of those problems from our services perspective? Well, the key one at the top of our stack is always our strategy and planning services. And this is where we get customers bought in. This is where you get your key stakeholders bought in, because obviously a UC transformation, when you're wanting to turn on voice, it's not just a voice project you're trying to do. You might be wanting to do a much larger project that's part of a mobility move. So BYOD could be part of it. It could be virtualization. It could be application virtualization. You could be moving to Windows 8. So we have a series of transformation experience workshops that we run with customers to actually get that CXO level buy-in to the project. And if you can get that buy-in to the project and to the concept right at the inception of the idea, even before you're even starting doing pilot, even before you're starting the project, those are the guys that can sit on all the different islands, all the different traditional islands in the organization and say, right, you talk to him and you talk to him and you talk to him and make this happen. So you as an admin or as the architect responsible for deploying Lync don't have to worry about trying to talk to those guys and getting them to work for your benefit. You can let the organization do that for you. One of the systems that we have available is a package UC solution at the bottom there called App System, which I don't know how many people have heard of Virtual System, HP Virtual System at all? Okay, so Virtual System is factory express built rack that we can deliver to you ready to go as a virtualization platform. So basically, when we leave site, you're ready to start spinning up virtual machines on it. It's a bladed-based solution. We took that concept and said, okay, how can we make a package solution for Lync for smaller organizations? So this system will scale up to about 3,000 users. Fully virtualized, but fully redundant as well, in the sense that we can lose any hypervisor and still maintain the whole user load on the remaining hypervisors. But it also comes with load balancers, with gateways, and optionally Polycom video integration as well. And we also have a series of services that cut across anything that we're doing from voice transformation to video to enterprise messaging, which might be Exchange-related stuff, and Office 365. So what's HP done internally with our Lync? We now have over 330, probably 350,000 users running on Lync. It is one of the largest, if not the largest, and most complex Lync environment. It previously was running, we started with OCS, but we have gone to full production now, full corporation worldwide on Microsoft Lync. 120,000 plus users using voice calling, and that voice calling is internal. That's not enterprise voice. So that's what we've got going on now. People are utilizing it for internal calls in preference to picking up the mobile and calling their colleague. Now, the data that stacks up from behind this, the reporting data that comes from IT, is really, really interesting to see how the user adoption has actually changed within the company and what people are using. But we initially rolled out with an IM&P, which just gave them instant messaging and presence, started to give them scheduled conferencing and peer-to-peer calling, and now we're rolling out enterprise voice. We've got something like 50,000 users now enabled for enterprise voice, a lot of the mobile workforce. And what we're not doing, and this is key to success of any project, is not going for a big bang, not just flicking the switch and say, okay, we've got 300,000 users out there using Lync in terms of basic voice calling, basic instant messaging and presence, web conferencing and collaboration. Let's just turn on enterprise voice. We haven't done that, and for very good reasons, because the problems that would ensue if we did that for 330,000 people all at once. Least of all, from a procurement perspective and a process perspective, we're talking a global deployment. We're talking multiple service providers. We're talking all the DIDs that have got to be done. You've got to do all the deals with your service providers for all your trunk provisioning, etc. And also, it's based on a rolling cutover process of when each site we're going to replace the PBX. We'll then roll those users over to Lync. And it's done on a business-driven calendar rather than, it'd be really nice to flick that switch and just save all those dollars for the company. All of our stuff is running on HP networking. Significant cost savings from just switching, getting rid of all the Cisco environment and putting pure HP networking in there. And that's been, again, used to refund other initiatives. The link at the bottom, if you follow that, look at HP Discover last year. So HP Discover 2012, there was a speech made by HP IT, and they actually gave a long presentation about our actual Lync infrastructure. There's some diagrams there that even at a high level are quite scary to look at in terms of the number of servers that's actually involved in this infrastructure to provide the resilience levels that we want from our voice services. But I do encourage you to go and listen to that because it's a very interesting journey. So where have some of our experiences come from? So Black & Veatch was one of the customers that we deployed a UC solution to. Started out as a small pilot, but the pilot went very successful. The customers wanted to move to up to full 8,000 users, but over 110 offices. So those 8,000 users are just spread around. So there's a lot of branches involved in that. And that's where a lot of the learnings about how to properly plan and cut over branches comes from. But the interesting thing, look at that money, $650,000 back to the business from just turning this on from 8,000 users. And going back to what I was saying earlier, don't necessarily return that money to the business straight away. Squirrel some of it away if you can. I don't know how, but try and hold some of that back, because you've released, if you release that much money to the business, you want to actually turn on, you may have not turned on other features in your UC stack. You may not have done full unified messaging integration. You may want to do some more collaborative work with SharePoint or something like that. Use that money that you've saved the company to say, hey, look, I can save you some more money. We can do some more great investment. So pull some of that money back. DRV was a channel-based solution. Smaller company, 47 branch offices, but again, complete networking refresh and UC solution from us. So, summary key takeaways. What are the three main things here? I mean, organization and political things will really trip you up. As I say, voice experience is really key. You're moving from something where the voice environment was managed by someone who has managed it for the last 10, 15, 20 years, and that's all he's ever done. And Lync is coming from left of field, and it's coming from someone probably who's managed Exchange, who's Office. He's an application-based, software-based engineer or architect. And you need this guy's skills. You need the skills, the language that the PBX admin and the PBX manager uses is not the same language as someone who's traditionally skilled in Microsoft technology. So you need that help. You need those people's help. They will be a great source of assistance when trying to sort out all the carrier discussions and your PSTN links and all that kind of stuff. And they will have all the information that you need. So that person needs to be your best friend. User experience. Monitor. And get proactive on everything. The more you can do to keep your end users happy as you start rolling out your enterprise voice in production, the better things will go for you. Don't just focus on your infrastructure. Don't just focus on keeping the lights on in the data center. Be proactive with your users, because in the same way that bringing your iPad or your tablet or your Windows Surface into the office as a BYOD device, if they get a good experience with that, can virally become a very good thing for the business. So can this. If you get those users on board, they will do the marketing. They will get everybody else using it. Sometimes always look at key projects. Find project teams as guinea pigs. People who are working, you may have a dispersed team across a number of offices or geographies. Get them involved as champions for Lync within your company and get them on board early on. And most importantly, don't forget the network assessment. Network is key. Network will let you down. Network will make your user experience poor before anything else. Primarily, your servers will be provisioned fine. Yes, you may accidentally unprovision or deprovision the amount that you need, so you may only have 4 servers in a pool when you needed 5, but you're not going to hit capacity from day one, but you will hit network issues from day one, the moment you turn the switch and give the green light to everybody to use it. But I do encourage you to stop by our booth just in the expo area and have a look at these devices, have a look at the routers, have a look at the SDN demo as well. Those laptops that we had in the video there are actually there running it, so you can actually see the impact of that for yourselves. Some key contacts within HP. Unfortunately, it's got the America's Solutions guy up the top, but if you contact Kent Johnson or Doug Wilson, they'll be more than able to help you with your services. And thank you very much. And please do not forget to fill in your evaluation forms. And I think we've got some few minutes, so if there's any questions, I'll be happy to take them. If you want to take them now or to chat with me afterwards, more than happy to.